Hello. Hello, everyone. And we are live for a new coding session. How's everybody today? Let me tell everybody that we are live right now. Can you guys hear me? You're here? Yes, okay. Boom. Up. Can you guys hear me? You're here? Yes, okay. Boom. Can you guys hear me? You're here? Yes, okay. Recursion. Can you guys hear me? Okay, you can hear me. Awesome. So today we're gonna try to do 3 exercises if we have the time. We have 2 hours together. The first one would be on pointers again. Again, we're gonna go through a very basic task to make sure everybody understands the basics, because once you understand the basics and how to work with those, it's much easier. Everything becomes like so clear and so easier. Then we're going to go through a task of recursion, and if we have the time, we'll do a singly linked list task. Sounds good? Oh, hello, Alex. How are you? So, let's see. Browser. So we're going to go through stream compare today. Okay, so this is a task where you need to write a function that compares 2 different strings. It takes 2 pointer to a char, so it points to the beginning of each of the strings. And then the function should, return an integer depending on whether or not the 2 strings are the same or not. Okay. So again, like remember from the last live coding sessions, when you go into an exercise, you want to read it, properly. You want to read the example. You want to make sure that you understand everything. And one of the things that the exercise is telling you is that this, the function should work exactly like string compare. So how does it work? How does it work exactly? So what should be the return value? For instance, it's, if the strings are the same, you're going to find this in the string compare manual. So let's switch to our terminal. Terminal's here, and you're going to type string compare, right? strcmp, to understand what it does return. So as you can see, this looks like a lot like the function that we want to write. And description is the same basically. And the return value here is what is going to be important for us to understand. So the string compare functions return an integer less than, equal to, or greater than 0 if s1, or the first n bytes therefore, is found respectively to be less than, to match, or to be greater than s2. Okay, so that means that if S1 is less than S2, then you're going to return a negative number. If it's the same, you're going to return 0. Or if it's greater than S2, you're going to return 1. Now, what does that mean in this context, that S1 is greater than S2? Can you tell me? What does it mean that a string is greater than another one? Tell me on the chat. Anyone? Except you, Alex. You're not allowed to answer. Okay, so I have like two different answers. The first one is the length of the string. The other one is ASCII character is greater than another. But in this case, which one? You know, there's a lot of different ASCII characters because there's a lot of different characters inside a string. Bam, you're saying by the values. The values of what? Okay, so we're not really sure, right? So why don't we go through an example? We have to do the same. We have to write a function that behaves the same way as the function string compare for the standard library. So let's just like use the standard library string compare to understand like what we have to do. Okay. So this is just an example program that we're writing to understand how string compare works. Okay, so we're gonna have an integer. We're gonna store the value of the function here, and then we're gonna print it. We're gonna use printf. This is an example, so we can do whatever we want. And okay, and then we're gonna compare two strings, you know, ABC with df, and we're gonna see what is working, right? So first we're gonna try to see if it is the length. Okay, so let's do like a string S1. In this case, S1 is this one, S2 is this one, and so let's see what it returns. Oh. H. What is the header file I need to include for string compare? Anyone? String.h. Okay, and now we're going to compile. Expect matching int. Oh, I forgot to pass the integer. Okay, and so in this case, it returns -1. Oh, wait, what? Oh, yeah, of course. Okay, so here we have a string which is longer than the other one. So if it's greater, in the definition greater, we don't know yet what it is. You know, we don't understand quite yet. It should return 1, like something greater than 0. Okay, and returns like -1. So it means that in this context, string compare thinks that the first string is less than the second string. Okay, so it's not a question of length. The second piece of information that we have gathered is that it returns -1 when it thinks that the string S1 is less than the string S2. Okay, so it's not a random number for string compare. It could be given the manual, but what it does is like it returns -1. So it probably returns +1, when it's greater than. So it probably has to do with, and some of you guessed it, the ASCII value of the characters. And it's not the total number, the total value of all the ASCII characters code. It is like letter by letter. Okay, so if we are comparing A to D, and then B to E, and then, and like as soon as something different, it compares the two ASCII values of those two characters, and then, like if the one is greater than the other, and that's when you have the return value depending on. Sorry. So A is less than D, and so it's going to return -1. So if we do F, for instance, if it starts with F, it should return 1 because F is greater than D. That's what it does. And so in this example, it's going to compare A with the first A, and then the A with the second A, and then the third A with the third A, and then the fourth A, And so like, so far, it's the same. And then as soon as it hits something different, it's going to return. And depending on which string has the character at this position higher than the other one, it's going to return 1 or -1. So in this case, it should return 1 still. Okay? And if we have the exact same string, it should return 0 because that's what the manual says. Okay? Any question about this? So I'm going to jump on the whiteboard, and we're going to try to understand what's the exact algorithm here. Okay, so let's just take an example. A, B, C, like that would be S1, and S2 will be, I don't know, like A, B, E, F. Okay. So what I want to do is like compare each letter at the same position one by one. So first I'm going to go through S1 and S2 at the same speed, starting at the same position, which is 0, like the first letter. So A, I'm going to compare first A with A, the first letter of each string, and then I'm going to compare B with B, and then I'm going to compare E with C, and then I'm going to compare etc., etc., right? And as soon as one of the letter is different, then I compare this letter with the other one, and if the letter in S1 is less than the letter in S2, then I'm going to return -1. If it's greater than the other one, I'm going to return 1. And the way I know if it's greater or less than the other letter is by using the ASCII code of the letter. Okay? Where do I find the ASCII code of each letter? Do you remember from the last session? There is a special table that you can get from the terminal to see what each letter is as an ASCII code. Oh, it's not working? Okay. Okay. Is it better now? Yeah, it doesn't seem to work. Yeah, I'm sorry, I have to... I don't know why it's not working. Give me a second, sorry guys. Let me restart. Hop. Yeah, I'm using a new whiteboard because last time it was not working well. It seems that this one is even worse. Okay. Tac. Okay. Delete. Yes. Plus. Okay. Okay. Okay, it doesn't show the whiteboard. I don't understand. Ah, what is happening? Okay, I don't know what's happening. I'm sorry, guys. I'm gonna try to use the last one. So give me a second. Very strange. Last one was Miro. The problem is that it was lagging so much. It was very hard. Yeah, like I don't know why. Like on my whiteboard on my computer, it's it shows like everything I write, but it doesn't show it on the stream. It's very strange. I look into this for next time. Okay, so let's see this one. Okay, delete. Yes, plus capture. Okay. Okay. So let's see if this works. Yeah, this one works. It's lagging a lot, but this one works. Okay, so let's go back. So we have S1, we have S2, and we have like two different strings. A, B, C, and another one, A, B, E, and we want to compare those two strings. So we know that we start at the beginning of each of the strings and we compare character by character, right? So we start at the first letter, and in this case for both strings it's the same letter. So we continue, okay? If they are the same, we continue. So B and B are the same, right? So we continue. And then E, C and E are different. So we're going to return the functions because the two strings are different. And if in S1, in this case, C, the ASCII code of the character C is less than the ASCII code of the character E. So in this case, we're going to return a negative number, maybe -1, maybe something different. I saw you guys in the chat. And then, like, let's just say this one was an A, for instance. Then A, no, it's the same thing, sorry. We say this one is an A, and this one stays a C. Then C is greater than A, the ASCII code of C is greater than the ASCII code of A, and so we're going to return a positive number, maybe +1, okay? And in the case where the two strings are the same, let's just do ABC and ABC. If they are exactly the same, right, then we compare each letter until we get to the end. This is the end. If we reach the end and all the letters were the same, then we return 0. Okay? Now, there are like some special cases that we need to think about. For instance, there is like A, B, and C, and it starts the same, but it continues. What happened in this case? If this is S1 and if this is S2, is S1 less than S2? No, it's not. If S1 is ABC and S2 is ABCD, is S1 less than S2? It's less than? Yeah, it's probably less than, but let's just double check. Remember, we have to have a function that behaves the same way as the string compare from the standard library. So let's switch to the terminal. And let's just like put this example here. And see what it does. And it returns -1. So it is less than the other one, okay? So if all the letters are the same when one of the string ends, but the other one continues, then this other one string is greater than the first one, okay? So now in the chat you were saying you have to return the difference between the two letters and not just -1 or +1. I'm going to double check that because like my string compare function is returning only -1 or +1. So let's go back to let's go back to the browser and reread everything, right? So here, your function should work exactly like string compare. But we have some examples. And in the examples, we can see that if S1 and S2 are hello and world, then it returns minus 15 or 15, depending on this, okay? Does this difference is the difference from the two, I guess, first character, because they're all not the same, in the ASCII table. So who remembers how we bring up the ASCII table in the terminal? What's the command I need to type to see the ASCII table? Anyone? Man ASCII, yes. So man ASCII. And so we're going to get to the letter H. H is 48, right? No, in decimal, H is 72, and W is 87. The difference is 15, okay? So we have to return the difference between the two letters in the ASCII value context. So going back to our whiteboard, we have to return the difference of the letters. Give me a sec. What's going on? I don't know. Oh, that's why. Okay. And so if we have C and E, the difference between C and E, so we're going to do this letter minus this letter, right? So the ASCII code of C minus the ASCII code of E, and the difference is going to be, anyone? Minus 2. Yes. And then if we have, what was the other example? C minus A is going to be Alice? If I compare C and A, I'm going to do C minus A. What's the result? Plus 2, yes. Okay, sounds good? So I think we understand now like everything we need to do at this stage, right? So we have the two strings. We need to start at the beginning, compare each letter one by one, and as soon as we find a letter that is different, we're going to return the difference between the two ASCII code of the two letters. If we get to the end of the string at the same time for both strings, then they're all the same and we return 0. Okay? Any question about the algorithm? So now we're going to say, okay, so we need the two strings. We have S1, we have S2, and those two are pointers. Okay, so that means that they are the address to the first letter of the string. Okay, same thing here. First letter of S1, and this is the first letter of the string S2. Okay, try to put that here. So just to make sure everybody understands what it means, I'm gonna go back to my memory template. Okay, and so when we receive S1 and S2, we have somewhere the string, the pointer S, or somewhere in the string in memory, we have somewhere the string A, B, C. Somewhere we have the string A, B, E, F, somewhere in memory. And then we have two new variables, which are pointers to string. The first one is S1 pointing to the first string. The second one is S2 pointing to the second string. So somewhere in memory, I'm going to have S1. S1 is a pointer to a string on a 64-bit machine. How many bytes does the string S1 take in memory? Anyone? How much space in memory does a pointer take on a 64-bit machine? 8. Yes, Jainam. It's 8. So somewhere in memory, I'm going to have, space reserved for S1. It's going to take 8 bytes. Okay, this is S1. And the value of S1 is going to be the address of the first character of my string, this string. So in this example, the addresses are completely random, but in this example, what is the value of S1 if it points to ABC? $81. Yes, Alice. Alice is on fire today. Okay, 81. This is the address of the first letter of the string ABC. Okay, the address is right here. Now, somewhere else I have S2. Let's just say here. It's a pointer to a char. So on a 64-bit machine, it takes 8 bytes. And the value of S2 is the address of the first letter of the string A, B, E, F. And the address in this case is 101. Okay? So now I have those two pointers. I can start comparing those two letters. Okay? So first I'm going to compare what is at the address 81 and what is at the address 101. And here you can see that they are the same. Okay, so next I need to move to the next byte, to the next character. Okay, so what I do is I'm going to need to move my pointer. So I'm going to do like S1 is equal S1 plus 1 and S2 equals S2 plus 1. So in that case, it's going to be 82, and then this one is going to be 102. Okay? Now I point to the letter at the address 82, which is B, and S2 points at the character at the address 102, which is B2. So at this stage, we compare the two letters again. They are the same, so I move on to the next letter. So I do S1 equal X1 plus 1 and S2 equals S2 plus 2, right? So now S1 is 83, S2 is 103. So S1 now points to C. S1 is 83, so it points to whatever is at the address 83, it is C. S2 has the value 103, it means that it points to whatever is at the address 103, in this case this is E. We compare the two letters, they are different, and so what we said is that we're going to return the difference between the two characters. So whatever is at S1 minus whatever is at S2, as soon as those two letters are different. And this is going to give you the return value. Okay? Now let's take another example. Now first, is there any question about this? Does it make sense? Any question? If you don't have any question, say no question in the chat. If you have a question, please ask it. There is no stupid question. And again, while I'm waiting for you to answer, because we have a 10-second delay, you saw what I did. I really understood the task at hand. I went through some examples. I whiteboarded it to understand, with human words, how does it work? And then do another step, a little bit deeper, but I still haven't coded anything, right? And then we're going to be able to get to another, step, a little bit closer to the code, and then we're going to code. But I haven't touched anything on my terminal. I haven't opened my Emacs yet, right? This is very important, step by step. Okay, no question. So we can move on. So let's take the example where the two strings are the same. Let's say ABC and this is ABC. Oh, and by the way, you remember that each of those strings ends with \0, right? So we go back here, points to 81, points to 82, to 101. Right, and so we do the same thing. So A and A, they are the same. We move S1 by 1 and S2 by 1. So now we are at 82 and 102. B and B are the same. So we move S1 equals S1 plus 1, S2 equals S2 plus 2. We are at 83. Okay, so now it's 83 compared to whatever is at 103. They are the same character, so we move on to the next character, and those two characters at 84 and 104 are the same, but they are special, right? They are special because their ASCII code is 0, which marks the end of the string. So we don't want to continue, right? We don't want to say, oh, they are the same, so we continue. No, at this stage, because they are 0, this is a special value, then it means that we need to stop. We're at the end of the two strings at the same time, so it means they are the same. So it means that in this case, you return 0. Okay? Now let's take another example where this one continues. Okay, and then we are A, B, C, and then we are here. And we can see that both are not 0. One continues. So if you do exactly the same thing, you do like the comparison between this and that, and that's what you get as a result. So in this case, the second string is going to be greater than the first string. So it's going to return a negative number because S1 is less than S2. And you're going to return whatever is at S1 minus whatever is at S2. And those letters, remember, they are stored not as letters, but as numbers, and those numbers correspond to the ASCII code of each of the letter. And you can find those ASCII codes in the ASCII table. Any question? So let's go back to the whiteboard. So we're going to do like kind of like pseudocode now. So we have int our function underscore strcmp char star s1 and char star s2. Okay, and then we're going to compare, whatever is at S1 with whatever is at S2, and if basically they are not the same, then we exit, we return from the function, and we return, we said, the difference, right? So S1 minus whatever is at the address S2. Okay, otherwise what we do is we continue and we say we move the pointer S1 by 1 byte, by 1 character, and we move the pointer S2 by 1 character. No, plus 1, not plus. It starts to lag a lot, so S2 plus 1. Okay, and then we do it again. If they are the same, blah, 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 blah. And so it looks like a loop, right? So we're going to say while something, then we're going to do all of this. Okay? So what is going to be the condition here in the while loop? Anyone? What is going to be my condition to stop comparing the two strings? The string value must not be null. So JNAM, you have the idea, but it's not exactly this. So the string value should never be null, right? The string value, I mean the pointer to the string, if it's null, then it points to, like no strings at all. And so when you're going to try to dereference it, it's gonna segfault. So you're not comparing the string, you're comparing like two chars, right? So Serdar, you're saying while what points at S1 is not null, or what points at S2 is not null. So there is a difference between null and \0, right? So maybe it's gonna work to compare null with a char, but null is not a char, it's a pointer. So you don't want to compare a pointer to a char, right? So you want to compare it to the char, you want to compare it to either an ASCII value, 0, or the corresponding like char in the ASCII table, which is \0. The value is 0 in the 3 cases, but it's not the same. So while S1 not null byte, so again, like S1 is a pointer, so you want to compare to what is at the address S1, not S1 itself, not the value of S1. While S at I is not null. In our case, there is no I. While string I is not \0. Again, in our case, we have no I. There's like different ways of solving this, right? But in this case, there's no I. So try to focus on like what we are doing, not what you have done, because otherwise it's not going to work. Try not to work on based on your memory. Try to work on like the problem at hand. When both strings and not \0. So Japheth, you have the idea, but it's not exactly that. You're never comparing strings directly. What's the difference between null and not defined? Okay, Pishu, ask me this question again, after we solve this one. I don't want to digress too much. Okay, anyone? Who's going to be able to tell me what I should put in the while loop? What is my condition to stop? We said it with words, right? When do I need to stop comparing the two strings? So if is while what at the address of S1 is not 0 or S2 is not 0. While S1 and S2 homojola. Yeah, that works too. So homojola, this works. Is there a way to say it like with a little bit more code so that everybody understands like easier? When S1 minus S2 equals 0. So this ALA, when S1 minus S2 equals 0 is going to work in 90% of the cases, but the problem is that when you hit the \0 for both strings, they're still going to have the same value and you're going to continue after the \0. So while S1 minus S2 equals 0 is not the right answer. When S1 equals S2. So if S1 equals S2, it means that the two pointers point to the same string, right? So I have while what's at the address of S1 minus what at the address of S2 equals 0. Again, this is going to work for most of the cases, but as soon as you have the same strings, you're going to hit the \0 at the same time. So what S1 and S2 points to are the \0, and so the difference is 0. So it's not going to work for strings that are the same. It's going to work for all the strings that are not the same, but it's never going to work for strings that are the same. Okay, we have while S1, what points at S1 equals what points at S2. If we do this, bam, then when you hit the \0 at the same time for the same strings, then it means they have the same value, so you continue. Dynam, same thing. So it cannot be while what's at the address S1 is the same as what's the other address S2. Okay, everybody's saying this. Okay, so let me show you. So a lot of people in the chat are telling me we should write this. S1 equals S2. Okay. So this is going to work for strings that are different. So for instance, if we have A, B, E here. So I'm going to continue while what's at the address stored in S1 is the same as what the address pointed by S2, right? So in this case, you know, if we start at 81, we have 81, and they're all the same, so you continue. And then your 82 and 102, they're all the same, so you continue. And here, they are not the same, so you exit, right? That works. But if we have the exact same strings, and my memory looks like this, I start at 81, okay? And they are the same, so I continue. And then I move the 2 pointers, they are the same, so we continue. I move the 2 pointers, they're still all the same, so we continue. I move again, and they are the same, and we continue if we have this condition. And then we continue until we find something random in memory that is different. But here we said that we should stop. Okay? So the condition while S1 equals S2 is going to work for all the strings that are different, but it's going to fail for all the strings that are the same. Do you guys get it? And by the way, it's the same. Like while S1 minus S2 equals 0 is also not the right answer because it's the same. While S1 minus S2 equals 0, right? Because in mathematics, you put like the S2 on the other side, it's like S1 minus S2, and then you have equal 0, right? So these two conditions are the same, and they are not the right ones because when you have like the same two strings, you're gonna hit the same at the same time the backslash 0, and what's pointed by S1 and S2 is still the same. So if they are the same, the difference is 0. So these conditions are not working. Okay, so what is going to be the answer? What should I put in my while loop? Here, what's the condition to stop? We just said it, right? The condition to stop is if we hit the backslash 0 at the same time for both. While, so atoms, you're saying while what's pointed at S1 is different, but what's pointed at S2 is the same thing. It's not going to work, right? Because when you hit the like if you have like a first letter that is different, then you're gonna stop. And what happens in our example? So Wadil, you're saying the value pointed at S1 is not 0, and the value pointed at S2 is not 0, and S1 equals S2. I think you have like I think you have the answer, but like it's, you know, like your condition, it might be too big. Okay, and thoughts, yeah, this works also. Okay, so basically what we want is that we want to stop when the two strings are hitting backslash 0 at the same time. So basically, when S1 is different from backslash 0 and S2 is different from \02, right? Okay, which is the same as what Tots were saying, which is the same condition as S1 and S2. Okay, but we're going to focus on this one because it's easier to understand. Okay, so as long as S1 and S2 at the same time are not pointing to a \0, we continue to compare the strings. If they are different, then we return the difference. If this condition is false, it means that they are the same, and so we move the pointers by 1 byte. Okay, and then we continue. Once we hit the \0 at the same time, then we get out of the function, and we will return zero. Because it means that if we get out of the while loop, it means that we have compared each of the character one by one, and we are at the same time, we are at the end of the string for both strings, and so they are the same. Okay? Can this work? Atoms, no, this doesn't work. Or more, while S1 and S2 different from 0. Yes, but you have to compare like S1 with 0 also. So yeah, so like you can this can work also if you replace the character \0 with 0. It still works. Why? Because the value of this char is 0. But since we are in the context of comparing characters, it's always good to use characters. Okay? So I'd rather see this. This works too, but I'd rather see the character when you are in the context of using characters and comparing characters. Okay? So now that we have like almost everything, we just need to code it. Okay? And basically we have done like 90% of the job. So this is the name of the function. Let me go back to the C project browser. Okay. So this is the prototype. I'm going to paste this in my, oops. Okay. So let's go to the terminal. And now we can code, okay? So we said while we're not at the end of the string for both strings, okay? So while okay, then I'm going to compare both characters. Okay, so I'm comparing. So if they are not the same, if S1 is different from S2, it means that the string themselves are different, and so we said that we're going to return the difference between whatever is at the address S1 minus whatever is at the address S2. And at those addresses, because S1 and S2 are pointers to a char, at those addresses they are chars. So what is stored at those addresses is the ASCII value of this character, as you can see it in the ASCII table, okay? And if they are the same, then you want to move to the next one. So you want to do S1 equals S1 plus 1, and S2 equals S2 plus 1, okay? if one day you get out of the while loop, it means that the two strings are exactly the same, because that means that you went through each of the characters that were the same and you hit the \0 at the same time, and so the strings are exactly the same. So in that case, you want to return 0. There is 0 difference between the two strings. Okay? And now we just need to do our main. So we're going to use the main from the example. I'm just going to copy it. And I think it's what? 3-main.c. Okay. Is this working? Yeah. Okay. In my main.h, I need to put the prototype of the string function, but I can find in the task. Okay. And I should have everything I need. Okay, so now I'm going to compile this. I just need to change. No error, so that's good. And then I'm going to run this, and I have the exact same thing that I need to have. Okay. So that is the end of the task. Any question? And so while I'm waiting, if you have no question, like please say no question, so that I know that you have heard me and you actually have no question. If you do have questions about the algorithm and the way we went through that, please ask them. But while I'm waiting for reading your answers, again, remember, I did not jump into the terminal and try to write my function. I really like step one is really try to understand everything about, you know, what I need to do, going through examples, try to find like every type of examples I can find to really see if I understand as a human what I need to return in that case. Okay. Then I whiteboarded, then I whiteboarded again, and then I whiteboarded again until I get very, very close to what I need to write. And then when you get to the terminal, you know exactly what you need to write. Okay, so never jump into the terminal and like your Emacs or your VI or whatever you're using to edit your code. You open your file only when you know exactly what you're going to write. You know, the key here is, again, whiteboard, 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 whiteboard. Never jump into the terminal or into the code. Oh, Saint UI, you're asking a great question. The question is like, what happens if the strings are, you know, are sharing the same beginning, one ends and the other one continues? Then at this point, both strings are not hitting the \0 at the same time. So you're going to compare S1 and S2. What points, you know, what they point to, okay? The two characters of the two strings. And then for the first one, it's going to be \0. For the second one, it's going to be D. So at this point, they are different. And so you return the difference between the two. So you return the difference between S1, like the character at this stage, which is \0, the code, ASCII code is 0, minus S2, and so the difference is going to be basically minus the ASCII code of D. Does that make sense, Saint? Sana is asking if we can use a for loop. Yes, you can use a for loop, you can use an index, you can use arrays. There's like a lot of different ways to solve this, but I really wanted you guys like understand like the step-by-step way of solving problems. Okay, use the memory table, Excel file that I shared with you, use the whiteboard all the time. Can you write while S1 and S2 different? So Alice, this is gonna work, but I want to make sure that you understand that this is probably not the way you want to write this. So let me try to. So Alice is asking if this is going to work. And the answer is yes, this is going to work. Why? So the second part is the same, right? S2 and S1. S2 compared to \0. The second part is the same. This is the same, okay? And this is a little bit different, this condition. But this condition is not you compare S1 with \0. This condition is like, this is a value. Is this value true or false? And since, once you point to the \0, the ASCII code is 0, and so the value of star S1 is 0, it means false in C. So it's the same as comparing S1 with \0. But you can't compare, I want to make sure that this is still working, Alice, but you can't compare those two at the same time with \0. You're not doing this. You're doing this, and then you're doing this. You're never doing testing if, what S1 points to is different from \0. You're never doing this, right? So this can work as a result. This is the same. Okay? And by the way, this is also working because the \0 ASCII value is 0. But again, I want to make sure that everybody understands we are in the context of comparing characters, so I'd rather see characters compared to characters. Alice, does it make sense? Okay. So Atobs is asking another question. Can we write the condition this way? Can we do this? And you can't do this because this is not proper C, right? So here you're saying you're comparing \0 with nothing here. When you're using this comparison symbol, you have to put something here. Otherwise, it's not going to compile. Okay? Probably what you meant was to do something like this. Right? You're comparing both to \0, but again, it's not proper. It's not how you write the condition. Here you're comparing this entire condition with this, which doesn't really make sense. Okay? All right. So do you guys need 1 minute of break before we go to the next exercise, or should we just jump into it? Recursion. Second one we're going to do is factorial. All right, it's 9:30. Probably should start right now. Okay. Okay, no, another question. The condition in the while loop, can it be written like this? I just answered that, I thought. Can you Okay, we continue. So favor, I'm gonna, yes, I'm recording this, so I'm gonna make sure that you can look at it later. Okay, let's move on. All right. Recursion. Who likes recursion? This one was one of my worst nightmares when I started coding. Very, very hard to grasp at the very beginning, but again, once you whiteboard everything, everything's going to be so clear. And then it's going to be like a very good tool for you to use in the future, especially when you get to, you know, advanced data structures like trees. You don't like it, Cedric? I didn't like it, neither at the beginning, but now I love them. Okay, so what is the task at hand? So write a function that returns the factorial of a given number. In factorial, int n, if n is lower than 0, the function should return -1 to indicate an error. Factorial of 0 is 1. Okay? So what's a factorial? Can someone explain to me in a very simple way what is a factorial? Anyone? Recursion is a nightmare. Okay. So, anyone? Factorial, what is it? We have like to create a function that returns a factorial of a number. We need to understand what is a factorial. What is it? Can someone explain to me? Anyone? Nobody? It's the product of that number through 2, 1. Repeated multiplication of an integer by its preceding integers, multiplying whole numbers of a number to 1. Okay. Yeah, Beryl, this is a nice one in a mathematical way too. Okay. So let's go to the whiteboard. Oh. Okay, how do I move this? Ah! I can't move it. Can't move it anymore. Okay, I can just tell it over. Okay, all right. Okay, so basically factorial n equals 1 times 2 times 3 until you do times n. Okay, so one example, if it's factorial 5, it is 1 times 2 times 3 times 4 times 5. It is also 5 times 4 times 3 times 2 times 1. Okay, until you hit the 1 or the 0. We know that there's an exception. Factorial 0 is 1. And if it's a negative number, we need to return -1. Okay. So take another example, like 3 is 3 times 2 times 1. Okay. And 2 is 2 times 1. Okay. So what you see here is an interesting pattern, right? So basically, like n factorial equals n times n minus 1 factorial. Okay. So for instance, 5 factorial of 5 equals 5 times 4 factorial 4. Okay, because it's 5 times 4 by 3 by 2 by 1, which is factorial 4. And factorial 4 equals 4 times factorial 3. And factorial 3 equals 3 times factorial 2, etc. Okay? So here, you can see the pattern of, what we could do. We could say, if I need to solve factorial of 5, it's just 5 times factorial of 4. And when I do, when I call my function again with 4, factorial of 4 is just 4 times factorial of 3, and so on and so on. Does it make sense? So I do this with 3, then I do this with 2, then I do this with 1, and at one point I need to stop. I need to stop at 1 or 0. Maybe I can stop at 0 because I need to solve 0 too, right? So when I do factorial of 1, it is 1 times factorial of 0. You can see the recursion right here, right? And at one point I need to stop the recursion, otherwise it's going to explode. And I know that if I am at 0, if we are doing the 0, we need to return 1. And we need to stop, because the factorial stops with the multiplication of 1. It doesn't go to the negative numbers, right? So you stop at 0. Okay? Does this make sense? So essentially, I'm going to have a function that was called, what was the name of the function? Factorial. Let me call it f on the whiteboard, right? It returns an integer, which is the factorial of the number. It takes a number as a parameter, right? And then what I need to do is just like the value that I need to return is n times factorial of n minus 1. Okay? And the only times when I don't do this is when I am at the value 0. So before returning this value, I check that my n is not 0. And if n equals 0, I return 1. okay? And essentially we are done with our function. Okay? So let me go to the terminal, and then in this case I'm going to do the terminal, and then I'm going to do the memory template to make sure everybody understands what's happening. Okay? But so far, do you have any question? Factorial of all numbers will be. So Naftali, what we said is that the factorial of 0 is 1. So whenever you hit the number 0, you just return 1, so that you don't multiply by 0. Right? So we just said the factorial of n is n times the factorial of n minus 1. Okay? So we just write this. N times factorial factorial of n minus 1. Okay? The only time when I don't do this is when I hit the 0. So if n equals 0, I return 1. Okay? So this is my function. And now I want to run it through the memory to make sure everybody understands. So let's go back to the memory template. Okay. I'm resetting everything. I'm going to put the code right here so that you can see it at the same time. Okay. So I'm going to call from the main function, I'm going to call factorial 4. And essentially I want to return the factorial of 4, right? So I'm calling this function with 4. So somewhere in memory, I'm creating space for this integer that is going to have the value 4. Okay? So somewhere in memory, this is an integer. So how much space is it going to take in memory on a 64-bit machine? Anyone? 4 bytes, Alice. Alice is on fire today. Wow, okay. So it takes 4 bytes. So let's just say it's going to be here, okay? So this is going to be n for my function. And the value of n right away is going to be 4, okay? So then is n equal to 0? No. So I return n times factorial of n minus 0, 1. So I'm calling factorial n minus 0, 1 here. N minus 1 is 3. So I'm calling the function again, okay? And then I create another space in memory for that new n. I'm calling this function again. So it's a n, another n, right? Somewhere in memory, 4 bytes. And this time, this is going to be 3. Okay? So I'm in my second function factorial. I compare n with 0, it's false. So I'm not getting into the if condition. And so I'm returning n times factorial of n minus 1. Okay? So I'm calling factorial 4. Now I'm in factorial. I want to return 4 times factorial of 3. Right? That's what I'm doing. Now I'm going to factorial of 3. Right? And I want to return 2 times factorial of 3 times factorial of 2. Okay, so I'm calling factorial again with 2. So I'm calling factorial 2 now. So I'm in my function factorial 2. I have another n somewhere. Just say here. And the value is going to be 2. It's still an integer, so it's still going to be taking 4 bytes in memory. Okay. So here again, I'm comparing n with 0. It's false. So I'm going to return 2 times factorial of 1. Okay? So I'm calling another time this function with 1 as an argument. Okay? So somewhere in memory, I'm going to have n for this context, but still is taking 4 bytes in memory. This time the value is 1. Okay? And then it's still not 0, so I'm going to return 1 times factorial of 0. Okay? So I'm calling factorial 0. Okay? And somewhere in memory I have another n. This time the value is going to be 0. Okay? And then I'm going into this function with 0, n equals 0. So now I'm returning 1. So now I'm going to get out of the function without calling factorial again. This is the end of the recursion, and now we have to go back to all the functions that we're calling ourselves. Okay? So let's just do that. So n factorial of this equals 1. So I'm going back to the function factorial 1, which was waiting for the result of factorial 0, and the result is 1. So factorial 0 is 1. Okay? So factorial 1 is 1, because it's 1 times 1. So now I'm exiting this function. I'm going to go back to factorial 2, which was waiting for the result of factorial 1. We know that the result is 1. So factorial 2 is 2 times 1, which is 2. So now I'm exiting my function, and I'm going to return to the function factorial 3, which was waiting for factorial 2 to give for factorial 2 to give the results. Factorial 2 is 2. So now I'm returning factorial, like my function, from my function factorial 3 into my factorial 4, which was waiting for the result of factorial 3. We know that factorial 3 is 3 times 2, so it's 6. Okay? And so therefore, factorial 4 is 4 times 6. And then from my main function, which was calling factorial 4 is 4 times 6. So this is 24. And so the result of factorial 4 is 24. Does it make sense? Any question about this? While I'm waiting for your answer, Wendell has a very good question. What if the number is that is passed is less than 0? Should we return a -1? Yes, we should. It's going to be the second step. This is missing, and we're going to have to add another if at the very beginning of the function to make sure that it works for negative numbers. Right now we have solved for every positive number, and we're going to solve next with negative numbers. But I didn't want to, I wanted to make it like as simple as possible to go through this example. So Caroline, you want me to repeat? No problem. Let's go through the example again. So I'm calling factorial. We're going to do it with factorial 3. So it goes a little bit faster. Now let's do factorial 4. Okay. So factorial 4, n equals 4. So is n equal to 0? No. So we're going to return n times factorial n minus 1. So factorial 4, right? So here you're going to return 4 times factorial 3. Okay? So in order to return 4 times factorial 3, you need to call factorial 3 and have the result of the return value of the function, right? The result of factorial 3. You're calling factorial 3, n is still not 0 here, it's 3. So you're going to return n, so 3 times factorial n minus 1, so factorial 2. So you're going to return 3 times factorial 2. In order to return this number, you have to have the result of factorial 2. Factorial, so you can't return right away, right? You have to wait for the result of factorial 2. So you return, in this case, factorial 2, n is not equals to 0, so you return 2 times factorial n minus 1, so 2 minus 1, so 1. And in order to return this value, you need to wait for factorial 1 to give you the answer. So factorial 1 is n is not 0, so you're going to return 1 times factorial 0. Okay, in order to return this value, you need to wait for the return of the value of factorial 0. And then factorial 0, n equals 0 in this case, so you return 1. Okay, so you can return this value right away because you don't need for another function to give you the result. So now factorial 0 is 1, so you can replace, so factorial 1, which was waiting for factorial 0 to return, is going to be able to return. And so it's 1 times 1, so it's 1. So now that we have the value of factorial 1, you exit the function, and factorial 2 was waiting for the result of factorial 1. Factorial 1 is 1. It's returning 1. So factorial 2 is going to return 2 times 1, so 2. And it returns, and it goes back to factorial 3, which was calling it. And factorial 3 was waiting for factorial 2. Factorial 2 is 2, so it means that factorial 3 is 3 times 2, so it's 6. Now factorial 3 can return to the calling function, which was factorial 4, which was waiting for it to return itself. And so factorial 3 is 6. So now factorial 4 is 24. 6 times 4. Okay? What if the condition is if n is less than or equal to 1, return 1? So it's not going to work because the negative number you want to return -1. Okay? Is it clear for everybody, like the example we went through? We haven't finished the function yet, but we are like solved for all the positive numbers. Any question? Caroline got it? Good. Okay, awesome. Okay, so now we need to solve for the negative numbers because we said that if n is lower than 0, the function should return -1. Okay, so we're gonna add that condition to our function. If n is less than 0, we should return -1. Okay. And now everything should work. So if it's a negative number, we return -1. If it's 0, we return 1. Otherwise, we return n times factorial of n minus 1. Okay? And that's it. Now let's just make sure that this works too. We're going to take the example from the task and see if everything works. So this is my main. In my main.h, I need to put the prototype of the function. This time it's factorial int. Okay, and now we're going to compile, and normally it should work. Factorial, the main is this. No, it's working on that. So factorial function factorial expected. Oh, I forgot the semicolon. Let's try again. Before okay. Here I forgot the parentheses. Okay, and now 3 times factorial, and we have the exact same thing as in the example, right? So this works. One thing that we could do is also, we don't really need to call factorial 0 once we have factorial 1. We know it's going to be 1, right? So you don't want to do this. So you can also do if n equals 1 or n equals 0, and this is gonna save you one extra step. Yes, Japeth, it's like writing Python. I forgot the semicolon, but I prefer C, so I'm okay. Any question? If you don't have any question, please tell me. No question, so that I can move on. Everything is clear and good. Thanks, Elias. Okay, Cool. So again, like I'm gonna repeat myself once again, but this is very, very important for your learning. Like never go and code right away stuff. You have to go through the exercise, repeat what you need to do with your own words to make sure you have understood, write it down if you need to, go through some examples, try to find special examples, and try to really understand what in each case you need to return without coding anything. You know, just like write this on a piece of paper. If you're lucky enough to have a whiteboard, like use a whiteboard. You can brainstorm together also. This is really, really nice. And it's gonna, you know, challenge everybody because everybody thinks in a different way. Then, you know, you whiteboard a potential solution. You go through steps, you find patterns. Oh, this might be a loop. Oh, this is how you move a pointer to another one. Oh, I don't really quite understand how you move pointers. You go and you use this Excel file and you do it step by step. Oh, a pointer is simply an address of another variable. Okay, so it's going to store the address when I dereference it, then that's where we are. You know, like each step at a time. Then you go back to the whiteboard and you might have, you know, go through like some back and forth with the memory templates and the whiteboard. Do this as many times as you need to in order to solve the problem at hand, okay? And, you know, once you understand, then you go to pseudocode. You try to get to the code like one step at a time, like closer to the code. And then when you know exactly what you're going to type in your terminal or in your like software, then, you know, you write the code. But you don't start by writing the code. Never do this, okay? Especially at the very beginning. Okay? Any question on the linked list? I have 15 minutes. We can try to do something, but I'm gonna need to stop in 15 minutes. So let me see. A basic one. Add node. What do you think about this one? I'm probably gonna be able to do like the whiteboarding, but not going into the code. But again, the most important thing is the whiteboarding. So let's jump into this. Hop. So add node. So for those who just started C, you probably haven't seen the linked list yet, right? But a linked list is, let me give you an overview. I'm gonna try to do this one. Let's go back to the whiteboard. Okay, still working. Okay. So, you know, in linked list, you're using a structure, a special structure, and you're gonna see what is a structure. Basically it's a collection of variables grouped together, you know, inside a new type that you create. That's pretty cool. But essentially in this structure, you have values, could be whatever it is, whatever you want. Could be an int and a char and a lot of things. But then you have a link, a pointer to the next structure in memory with the exact same type. So it holds the exact same type of values inside them. And then you have another pointer to the next structure in memory, and so on and so on. And just as for the characters, you know, like for the strings, there's a one character after the other. It ends with the \0. This time, the last structure points to nothing, points to null. The last pointer is the null pointer. It points to the memory 0, okay, which you can't address, okay? So that is the way we know we are at the end of the linked list, okay? If you haven't seen this, it doesn't really matter. You're gonna see this later, but just wanted to make sure that if you stay, you have an understanding of, overall what we're doing here. So in this exercise, we have a linked list and we want to add a new node to the list, right? And we want to add it at the beginning of the list. So imagine you have a list like this. This is an example. It ends with the value. It ends with null. Okay. The first step you want to, so you have a pointer to the first element of the list, right? Just as you have a pointer to the first character of a string. Okay. And you want to create a new one. Make it point to the previous first one so that it becomes the first one, and have this pointer now pointing to the first new one. Okay, this is how you add a node to the linked list. Makes sense? Yeah, Judith, you can put your question here, and I'm gonna try to address it if I have the time. Okay, so so this is what we're gonna do. So in this case, unlike everything you manipulate at the very beginning, here you're gonna have to create the space for this element in memory. Okay. This element is of type, oh, sorry, I was not in the whiteboard. Let me restart. Okay, so let's just say that each circle is a node. You have a linked list, so each node points to the next one, and the next one is not exactly next to it in memory, it could be anywhere in the memory. So you have a pointer that points to the next one until the last node points to null. That's how you know this is the end of the linked list. So most of the time you have a pointer that points to the first element of the linked list, so the first node. Okay, so it points to the first byte of this node in memory. Again, this node is a structure that can hold like a lot of different things, but one particularity of this structure is that it has a pointer to the next node. Okay, so what I want to do in this exercise, I want to add a new node at the beginning of the linked list. So first I need to create this node in memory. Okay, and then I need to make it point to the previous first node. Okay, and then I want to have this pointer point to this one, which is the new first one instead of the past first one. And now I have added a node at the very beginning of my linked list. Okay, makes sense? The exchange, I shared the memory template already like several times. It is normally in your intranet. So when you're gonna go and read like everything about pointers and arrays, at the very end of this page, you're gonna find the template. Well, let me put it here. Okay, is it working? Yeah. Okay. Okay, let's go back to the task at hand. Okay. So does it make sense so far? So the first step, is create the node. I really need to find a better whiteboard. The second step is try to find the address of this node so that this new node can point to it. Okay, so update, like, or maybe like points. Oh, it's horrible. Points to old first. Okay, and then you have the address of this because you have created it and you manipulated it so that you can tell pointer to point to it, right? So in the project, you want to return the address of the new element of null if failed. So then you can just return the address of this new node. Return address of new node. Okay, this is not working anymore. Okay, so I'm gonna pseudocode it in the terminal, and I'm gonna try to set up another live session to go through that. List, let's see. So essentially you're gonna have like a new node of the same type, right? List T new. You're gonna have to allocate enough size in memory to create this node. So size of list T, okay. Oh, everything like regarding scores, I'm not the right person. You should ask on Slack, Judith. Okay, so I did the first thing. I allocated enough memory for my new node. Okay, so now I need to have this node point to the old new one, which is stored in head. So new next equals head. Okay, and then I'm going to return new. Okay, so there's a lot of different things we need to check, but I have to go. But there's a lot of different things we need to check at each point. So first, here malloc can fail. So you really want to make sure that malloc has not failed before you continue. The other thing that can happen is that this head can be empty. Can be like you can have like null. So is this working or not? I'll let you think about it, and then you return new if it has worked. But essentially, these are the three steps that we talked about. You create space for the new node. You make sure it points to the old new ones, and then you return the address of this new node. And since we have already a pointer to this new node, you return the pointer right away, right? The variable new, which is a pointer to the new node is going to be destroyed, but the new node is going to stay in memory because you have allocated memory for it, right? But you haven't freed it yet. So when you go back to the main function, it still exists. And since you have returned the value of new, which was containing the address of this new node, even if new is destroyed, the value of new is passed to main so that you don't lose the address of the new node. Okay. So guys, this is just an introduction to this exercise. Try to think about what I just said for those who are like working on this, so that we can like try to see, you know, like next time when we go through that, we try to see like, you know, where we need to improve together. Okay. So with that being said, if you don't have any other question, I'm gonna wait like a few seconds. But other than that, this is the end of the session. And again, while I'm waiting, whiteboard, whiteboard, whiteboard. Like, if you need to tweet something today, tweet whiteboard. Okay, guys. I'll see you very soon. Thanks a lot for staying with me. I hope you got something out of it. And yeah, happy coding.